All right, guys, you're going to be doing 4.2.3 today. So there's some different ways we can model probability. The deal is I want you to actually try these things, try the lessons, hit pause on the video, and then you can watch the video again and kind of figure out it. Obviously, there's no way for me to make sure that you're actually doing that. So I'm just going to trust that you're actually doing what I think you're going to do. Okay, so we're going to start off with 475. Okay, you're going to play a variation of rock, paper, scissors. Okay, you need to get a group of 4. If you need to join up to go to another group, that's fine. Get 4 people together. If you don't have 4, you can play with 3, but we got to have 3 or 4. If you have 4 person, one person's going to be the recorder, the other 3 play the game. If you only have 3 people, okay, then just one person records while they play. Okay, label someone player A, someone player B, someone player C. Okay, figure out what you think is going to happen. A gets a point whenever everybody matches. B gets a point when 2 of the 3 people match. So 2 rocks, 2 papers, 2 scissors. C gets a point each time nobody matches. Everybody's all different. Okay, who do you think is going to win the game? Okay, now actually play it. Go at least 20 times. I would say even maybe go 30 times. Okay, recorder, keep track of the points and see who you think is going to win. Do you think it's going to be fair? Okay, so just it's whatever you think it is. Now you're going to actually figure out what do you think the probability actually is. Okay, well, there's 27 different outcomes, right? Because you can have rock, you can have paper, you can have scissors, okay? And it's 3 people, 3 times, so there's 27 outcomes. Well, the only way that you win if you're player A is if it's rock, 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 scissor, 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 or paper, 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 okay? So player A is going to be 3 out of 27, which is 1/9, okay? The only time, okay, that you're going to get that nobody matches, okay, is if you go rock, paper, scissor, rock, scissor, paper, paper, rock, scissors, paper, scissor, rock, or scissor, paper, rock, scissor, rock, paper. So there's 6 of them. Okay, so B is going to be 6 out of 27, which if you divide both of those by 3, you get 2 out of 9. Okay, now everyone else is going to be the leftovers, okay, where at least 2 people match. That means that there's going to be 18 out of 27, okay, which comes out to be 2 out of 3. There's a 2/3 chance, okay, that C is going to be a win. Like they should be the winning because they get points more often. Okay. Now come up with a way you think that's going to be fair. Okay. Just come up with some ideas to see how can we make this a more fair game. Okay. So now there's a new game at school called Pick a Tile. One of the players reaches into 2 bags, chooses a square tile and a circle tile. Squares has 3 yellow, 1 blue, and 2 reds. The bag with circles has 1 yellow and 2 reds. In order to win the game and a stuffed animal, you must choose 1 blue and 1 red. Okay, since it costs $2 to play the game, Marty and Jerry decided to play it, calculate the probability of winning before deciding whether to play. Jerry suggested making a systematic list of all the possible color combinations. Okay, so listing everything. So we got square, then circle. So Jerry says the answer is 1/6. That doesn't seem right, says Marty. There are more yellow squares than blue ones. I don't think the chance of getting a yellow and a red should be the same as getting a blue. So we're going to make a tree diagram for the situation. Okay, so if we make this tree diagram, okay, our first choice, we could either get a red, a blue, or a yellow, right? Those are our first choices. Okay, well, the probability of getting red is 2 out of 6. Probability of getting blue is 1 out of 6. Probability of getting yellow is 3 out of 6. Okay, so that's based on our squares. Now we also got to get our circle. Okay, well, our circles from here, okay, we either have a yellow circle or a red circle. Yellow circle, red circle. Yellow circle, red circle. So yellow is 1 out of 3, 1 out of 3, 1 out of 3, and then the other ones are 2 out of 3, 2 out of 3, 2 out of 3. Okay, so the probability of a player choosing the winning combination is a blue square and then a red circle. So blue square, red circle. Okay, so blue square, red circle is getting a blue and then a red. So the probability of getting a blue and then a red is 1/6 times 2/3, which is 2/18, which is 1 out of 9. Okay, so C, should they play the game? Okay, do you think so? Well, we've got a 1 in 9 shot of winning, but that also means that we've got an 8 out of 9 shot of not winning. Okay, so there's only about an 11% chance that we're going to win this game. I don't know about you, that's probably not very good probability, probably not good odds of being able to win. Okay, let's try this next one. So draw a probability area model for the pick a tile game. Okay, so we're going to try to do this area, this area model now. Okay, so the first time, okay, so here's our area model. Okay, we got the probability of yellow, we got the probability of red, and we got the probability that we get a blue. We got 3 different options here. Okay, so yellow is 1/2, red is 1/3, blue is 1/6. Okay, so that's for our squares, and then our circles, we got the probability that we're going to get a red circle, it's 2 out of 3. The probability that we're going to get a yellow circle is 1 out of 3. Okay, now we just find the area. These guys here, okay, that's 2 out of 6. Okay, this one here is 1 out of 6. This one here is 2 out of 9. This one here is 1 out of 9. We got 2 out of 18. Okay, and then we got 1 out of 18. Okay, so now we could figure all those things out. That's if we kind of see everything all together in terms of, you know, common denominators. This guy is 6 out of 18. Here's 3 out of 18. Here's 2 out of 18. Here's 4 out of 18. 6 plus 3 is 9, 13, 15, 17, 18 out of 18. So everything is all together. So it's called an area model, okay, because you're finding the area of each rectangle, just the length times the width each time. Okay, just length times width to find out which one. So now, if we look at the ways to win the game, okay, we said to win the game, we have to get a blue and then a red. So blue and then red is right here. So 2 out of 18 that we're going to win. Okay, so C-Seg, which one would you rather prefer? It really doesn't matter. Okay, it's whatever you want. It's completely whichever one makes more sense to you. Me personally, I like the area model because it makes it look a little bit better. And it's a little bit neater. Okay, but if you like the tree diagram, you're totally good. Okay, could you have done it for rock, paper, scissors? Okay, well actually you can't because there was 3 possibilities. We can only use area models when you have 2 situations. Okay, we had 2 bags. First bag, second bag. We had the squares and then the circles. We couldn't do it for the rock, paper, scissors because it is three things. Okay, so that doesn't work. All right, so here you go. Next one. Rimshot McGee has a 70% free throw average. The opposing team is ahead by 1 point. Rimshot's at the foul line for a 1-and-1. Okay, so you basketball players, you know, if you take the first shot. If you make it, you get a second shot. If not, you don't worry about it. Okay, and everything's worth a point. So what do you think is going to be the most likely outcome? Okay, just make a guess. Figure out, do you think it's going to be 0 or 1 or 2? You never know. Okay, now B, try to make a tree diagram, okay, based on this guy, right? So we're going to go 2 different shots, okay? So here's our first shot. We got here is going to be a make, and then we got a miss. Okay, well, if it's 70% chance, that means that's 0.7 that we're going to make it, but it's also 0.3 we're going to miss it. Now, we make it our second shot, we're either going to make it or we're going to miss it. If we make it again, it's 0.7%. If we miss it, it's going to be a 0.3%. Okay, now we don't have to put anything else here because we don't get a second shot. Okay, so the probability that we get 2 points because we went make is 0.7 times 0.7, which is 0.49. Okay, the probability that we get 1 point, okay, or 1 points, that's weird, okay, is a make with a miss. So that's 0.7 times 0.3 is 0.21. Probability we get 0 points, okay, is just we miss our first shot, we get nothing. So then that's 0.3. Now double check, 0.49 plus 0.21 is 0.70. 0.70 plus 0.30 is equal to 1. So that means it came out to be the right way. Okay, now we can also go ahead and look here. Okay, look at our area model. 0.7 times 0.7 is 0.49. 0.7 times 0.3 is 0.21. Down here is 0.30. Okay, which are the one getting 1 point? Okay, so 1 point is going to be this stuff right in here, because you made the first shot but missed the second shot. Okay, so we can look at that one and we can do the same thing. Okay, now what's the probability that we're either going to get a 0, okay, or a 2? The probability of a 0 or a 2. Okay, the probability we get 0 or 2, okay, is 0.49 plus 0.3 is 0.79. There's a 79% chance we're going to go all or nothing, which means, and there's also a 21% chance we only scored 1. Okay, so the most likely, okay, is going to go ahead and be, it's not this one. The question is just saying, what's the probability of getting 0? What's the probability of getting 2? Which you already did. We answered those questions. Okay, most likely is that we're going to go ahead and get 2 points. Okay, very nice. Okay, now let's look at the area model. Okay, so looking at 79 here. Okay, what's the dimensions of the whole thing? Okay, well, it's a 1 by 1, right? Because we have 100% of one and 100% of the other. Okay, what's the total area? Okay, total area is still going to be a 1, because if it's a 1 by 1, you still get it up to be 1. Okay, now what events are represented by the entire area model? It's the probability, okay, that he will score 0, 1, or 2 points. That's what the whole thing represents. Okay, now if we looked back here at B and we actually did some math based on it, okay, we're looking here, the dimensions of this guy is 0.3 plus 0.7, and then the other one is 0.3 plus 0.7. Now if we were actually doing like the math here, right, we could actually do that, and we're going to get the same answer, and we can get that, but it comes out to be, it's going to be a 1 by 1. That's what area models kind of come out nice. Okay, so you finish this up, you've taken on the notes, hopefully you followed along with it, made a little bit of sense, it helps you out. You're going to be able to take a break, and then you can move on to the next section.